Akhil Kumar from India, and I'd like to share a few my research thoughts regarding wireless energy transmission with you. Today's my topic is wireless energy transmission. What is the necessity to transfer energy from space to Earth? You know, Earth is having a shortfall of energy. There is a crisis of energy on Earth, and we are having a lack of infrastructure on Earth to transfer energy. Whereas when compared to space having a very vast amount of energy, abundant sources of energy, solar energy. So is there any possibility to transfer this energy to Earth, then we can come out with all the problems, we can solve the energy crisis. So why we use exclusively wireless energy transmission process? You know, for example, if you generate energy in space, it will be somewhat at very far distance. So we need something which is wireless. We can't use wires because there is a lot of distance. So energy transmitted from space to Earth is in the form of laser beams. If you can transfer energy in the form of lasers, it will be the most efficient process. We know lasers are the most economical way to transfer energy. Why I choose lasers? Lasers are monochromatic. You know, it's a single wavelength transmission. And pulse is maintained better over longer distances. We know there is a long distance, a larger distance. So at the same time, wavelength is also considered as an important factor to transmit energy. So we are comparing here the transmission process. We will have a transmitter and a receiver at the two extremes. In between there you will find a transmission process. A transmitter is nothing but that transmits energy from in the form of optical waves. So the transmitter, the initial component here, it's optical signal transmission. It is positioned whether in a space settlement or some other satellite that will transmit energy in the form of lasers. This transmitter converts the electrical energy into light signals, optical signals. This has an optimum wavelength range. We are using neodymium doped yttrium aluminum garnet as a transmitter here. It's an effective transmitter. So semiconductor laser diodes are also used as good transmitters here. Coherent light is also produced. So it is a stimulated emission. We know about from Newton's laws, we know about what is stimulation, and through that we can emit energy. A transmitter, it can produce an output power of 100 milliwatts. It's having a short recombination time, and it can be modulated directly and easily with high frequencies. And this transmitter is the best way to transmit energy. So here the beam exclusively works on lasers, and it having a good meager deviation in space. You know, if you want to transmit energy, you should have a single wavelength because the receiver can't have a huge amount of area. And the transmission process here you will find the most important things, the features of transmission is narrow beam width. It's angular range of antenna, beam width, angular beam width. At the same time, a narrow beam width is a good property you have to have a good transmission. And large directivity. Directivity is a measure for radiation's pattern intensely in a specific direction. For example, if you want to have a good transmission, the directivity should be large. At the same time, the bandwidth. There is a lot of difference between beam width and bandwidth. So beam width should be smaller, whereas bandwidth should be higher in frequencies. So larger bandwidth supports higher good transmissions. Bandwidth is a transmission of signals in the form of frequencies. And now comes to the point-to-point links. You know, you need to have accuracy in transmission. You need to minimize the losses in transmission. We have to compare the energy required to transmit. It should be lesser than the energy that is being transmitted. So point-to-point links are very necessary. And now here, let's come to the receivers. Receivers are nothing but they do the opposite exactly to transmitter. It is the main component in this receiver is photodetector. It can detect light. So it works on the phenomena of photoelectric effect, where when a light is transmitted, it should be received with some receiver. So this receiver is constructed with a photodetector inside it so that it can detect the light and it can receive it. This photodetector converts optical beams into electrical beams. Through receiver, we converted the light energy into light form, optical signals. Here, the receiver converts the light signals into electricals. And this is a wireless energy transmission which requires a good perfect components. here we need components that are in good condition. Good quality components are very necessary for this wireless energy transmission. Thank you.